Hey everyone, today we're going to do exponential function regressions, and this is where we find a line, or rather a curve, that fits our data. So this is the problem we're going to use. If you take out that worksheet and grab either a calculator or a Desmos, I'm going to actually show you how to do it on Desmos, and I'll make a follow-up video where I show you how to make it on a calculator. So what I want you to do is first plug in that data into Desmos. I've already plugged it in here, and you notice how I've got it typed in. That right there is how you want to type it in. So you're going to plug in that data first before you type in the thing below it, and you do that by pressing plus and then the data table, and then you need to type in y1 tilde ab to the x1. I typed in the AB because this is the form for an exponential function. I know this is exponential data, well, because I made it, but we'll talk about why we know that later. And then what you'll need to notice is the equation is f of x equals 18,029 times 0.741 to the x. And I got that from A and B. So go ahead and I'll pause it here because you need to have Desmos. And yep, now that you've unpaused it, thank you for doing that, and we will finish this video. So I'm going to be referencing that a lot. Go ahead and make your table, or make your chart. That's the number of years after it was bought, the car was bought, and this is the cost of the car. So I have going all the way up to 20,000 because we start at 18,000. That's the highest it will be because it's decreasing in value. So I'm going to go ahead and plot each of these points, and you notice I'm just plotting the points that were already given to me, and I know what it looks like, so I'm going to go ahead and graph that. The thing that's important is that down here we cannot have the line, it should not be touching the x-axis, so make sure you don't have it go all the way down, but it should get pretty close like that. And remember, we call that an asymptote. And we already found the equation in Desmos, so I'm going to go ahead and put that there. And let's answer these few questions. According to the equation, what is the value of the car after 5 years? Well, I'm going to look at where x equals 5, and you can actually type in x equals 5 into Desmos, and it will get you this value. Another way of doing that is you could plug in x into this function right here, and if you did 18,029 times 0.741 to the 5th power, then that would give you 4,028. Now I rounded that to the nearest dollar, which is close enough, and I'll be careful to specify how much I want it rounded on quizzes and tests and the like. For the next problem, we're actually going to set up when is the car worth $2,000. That's the y value. On Desmos, you'll want to type in y equals 2,000. And when you get that, you get x is approximately 7.335 years, and that is the years after the car was bought. Now, this last question, why would a linear equation not be a good fit? If we made a line out of this data, or tried to make a line out of this data, it would look something like that, and that line, you notice, eventually becomes negative. So the linear equation would not be good, because what that would mean is that the car you have has negative value. And it doesn't really matter how old your car is, even if it's just a piece of scrap metal that won't run, you can find someone who will pay you something for the car. So there's no reason for it to have negative value. Well, thanks for watching this video. I hope you learned something. Have a good day.